All right. Good morning, learners. Okay, if it is morning, good afternoon. If it is afternoon, it depends on the time of the day we'll be watching this. All right. Today, we are still going to continue with our lessons on algebraic expressions. So remember the last time we managed to do the following. We managed to achieve recognizing, identifying the convention of writing algebraic expressions. We also managed to identify and classify like and unlike terms in algebraic expressions. So today what we'll be doing, we'll be actually going to recognize and differentiate between what monomials, what binomials are, as well as recognize and identify the coefficient and exponents in algebraic expressions. All right. So the last time, these are the activities that we did concerning that. All right. And today we start here. All right. We're going to start here in recognizing and differentiating between monomials, binomials, and trinomial. Very importantly, a polynomial is an expression made up of the sum or difference of terms. Therefore, if we refer to a polynomial and we say it is made up of the sum or difference of terms. Terms, they can have 2 terms, it can have 3 terms, it can have 4 terms, 5 terms, and as many terms as possible. It is actually going to fall under what we call a polynomial. But an expression with one term, an algebraic expression with one term, we call it a monomial. The one with one term, we call them a monomial. In this case, we actually took an example of 2xy. Can you see 2xy in this case? It is actually written as 2xy. It's a monomial. So why is it a monomial? Because it is just one term. It's one term. It's one term. Why is it one term? It is not separated by a, let me say number one, it is not separated by a plus or minus between the terms. So if it is just one term like this, we call it a monomial. All right. The other term, which is a monomial, be very careful. The manner in which it is written there as 5 into x minus y. And you remember what a term is. A term, it's actually supposed to be having the plus or minus sign between the terms. But in this case, 5 as well as x minus y, they all form the same thing. It's not the same as written like 5x minus 5y, whereby 5y and 5x are separated by an operation sign minus. In this case, these are 2 terms, but in this case, this is one term. This is one term. So it's also a monomial. All right. The other example there on monomials is 2 into x minus 3. You can look at this. It is this one. 2 into x minus 3 all over 5. This is written as the same fraction. So if it is written as the same fraction, it means it is one term because there is no plus or minus sign separating the term. So it is one term. So because of that, it's a monomial. All right, we'll actually go to binomial so that we can actually see. When we actually say it's a binomial, when we talk of binomial, a binomial is 2 terms. two terms. In this case, it's a term 2x, which is actually separated by a plus sign. In this case, 2x plus 4. 2x plus 4, it is going to be a binomial because you will be having a plus sign, which is an operation, and this is another term, and this is also another term, and because of that it is two terms. So when it is two terms, it's a binomial. All right. The other good example there is of negative 3x squared minus 5x. Can you see that? A negative 3x minus 5x is also called a binomial. Why do we call it a binomial? There is a sign that separates the two. Can you see the sign? Which is a negative in this case. And there's also a term here. This term here is also a term. And then the other one there is another second term. So there are two terms. So if there are two terms, we say it's a binomial. All right. The other one there under the binomials, we also have this one. Can you check this one? This one is written as 2x minus 3. Can you see that? Minus 3 plus 2. Right, if you check there, can you see that it is a term, subtract another term. This is a monomial. Can you see that? So it's a term, it's a term. So because of that, we have two terms. So if we have two terms, we also have what we call a binomial. All right. Let's go and check a trinomial. Very interesting. Trinomial. Can you check the terms? Mono, it's a single, but it means one according to the Greek language. And then bi, it's two. And tri is 3. All right. Remember bi from bicycle, which is 2 wheels, 2 cycles. And tricycle, which is 3 cycles. In this case, we are having 2x plus 3y minus 2. So this and this are not like terms, and that one. So we have 1, 2, 3 terms. So if it is written like that as 3 terms, we say it's a trinomial. All right. So, okay, let me write it here so that you can actually see it separately. It is 2x plus 3y minus 2. Can you see that? 2x plus 3y minus 2. 2x plus 3y minus 2 is term 1, separated by the operation sign. The second term separated by the operation sign. So it's going to be 3 terms. So if it is 3 terms, we call it a trinomial. All right. So this is a trinomial. Another good example they teach there. It's negative 2ab plus BC minus 4C. All right, this is B, not 6, it's BC. All right, then it is negative 2AB plus BC minus C. We have two operations that are separating the terms, so therefore we have 3 terms. So if it is 3 terms, we call it a trinomial. All right, very interesting name. Fine. Now let's go to the other one. We are going to be recognizing and identifying coefficients and exponents in algebraic expressions. So this is 4a squared plus 5 is equal to 12. But you must note, when an expression has an equal sign between, if two terms, one term is separated by an equal sign, it is no longer an expression, but it's an equation, because now you have an equal sign. So this is not an algebraic expression, it's an algebraic equation, all right? But in this algebraic equation, this side of 4a squared plus 5, it's an algebraic expression which looks like 4a squared plus 5, all right? So we read it as 4 times a power of 2 to the, you say 4 times a to the power of 2 plus 5. You say 4 times a to the power of 2 plus 5. We read it as that. We can say 4a to exponent 2, 4a exponent 2 plus 5. That is how we read it. So in this case, very importantly, the number next to the variable here, which is a, this number, we call it a coefficient. And then the variable in this case is a. So in this case, a squared here, it's a base here of that particular exponent, but the base of that power, the power here is 2. So this is the base of the power, the base of an exponent. Can you see that? So the base of the power here, it is 2. And then from there, a is a base, and then by the variable, and then plus 5. 5 is a constant, wherefore it's coefficient of a square. We'll actually do more of this so that we can actually see. I'll actually do an example with you now so that we can actually see how these things are actually done. A degree of writing of an algebraic expression. A degree of an algebraic expression, when we actually refer to what we call a degree of an algebraic expression, is one variable which is in the highest power of that variable in the expression. All right. Therefore, in one expression, we're actually picking an example in this case, which is 4, which is having the power of 1, x which is having the power of 3, another x which is having the power of 2 in the same expression, which is the polynomial in this case. The one which is actually having the highest power in this variable, that will be the degree of this expression. So when we say a degree of an algebraic expression is one variable in the highest power of that variable in the expression, we'll be actually referring to this highest one from this other two, because this is the highest, which is 3, this one comes 2, and this is 1, which is the lowest. Therefore 3 is the highest, and because of that, we'll be actually saying the degree of this expression is third degree. It will be the third degree. So when simplifying an expression, we usually write the terms in an ascending, or we write them in a descending order of powers. All right, let's actually come to this example. Our example in this case, it is this one, a minus 2. Can you see? It's minus 2x minus 2x minus 3 plus 4x cubed minus 5x squared as an expression. All right. So that is it. So one thing that we have to do in this case, we have to write these in the descending power. The question said in this case, write the expression in the descending power of x. Meaning that if it's descending is going down. Ascending is actually stepping up. Descending is stepping down, all right? So ascending, in this case, they say write the expression in the descending power of x. When you write this in the descending power of x, it means the highest exponent will be the one that's going to start. So it's going to be x cubed that starts, so it's going to start as 4x cubed. Remember what I said about the positive when the coefficient is written positive and when it is also not written. We said even if it is not written, it is still a positive. All right. We said that in our last lesson. And then what comes after power 3, it is power 2 minus 5x squared. And then after a power of 2, that's supposed to be power of 1, which is there, 2x, which is going to be minus 2x. And then the last one will be, which one is next now? Is negative 3. Can you see that? It's the only one left, negative 3. So when we've actually written like this, you have actually written it in the descending power of x. All right. And then the next question there says, how many terms does this expression have? The number of terms. Number of terms, we have to count how many terms is 1, 2, 3, 4. In this case, it is 4 terms. All right. All right. The third one. Can I show you? Can I show you that? Sorry. Okay, there is it. 4 terms. It is 1, 2, 3, 4, and that is why I'm actually saying 4 terms. All right. And then the other question says, what is the value of the constant term? A constant term, remember what we said about the constant? The constant term is the one which does not have a variable. Then 5 here is a constant term. So in this case, we're also going to check which one is a constant term here. Can you see that? Which one is a constant term? It's negative 3. So negative 3 is a constant term. Why do we call it a constant term? Is because it has no variable. Okay, so this one, it cannot be a constant term. It is coefficient of x. This is coefficient of x squared. This is coefficient of x cubed. All right, let's check the next question. The next question says, what is the value of the constant term? We answered that. What is the coefficient of x squared? What is the coefficient of x squared? Now, x squared in this case, there is it. Can you see our x squared? There is our x squared, negative 5x squared, negative 5x squared. They say the question is, what is the coefficient of x squared? Therefore, we are referring to the number which is next to x squared. In this case, the number which is next to x squared, this is x squared. This is the coefficient of x cubed. This is coefficient of x squared. This is coefficient of x. We are looking for the coefficient of x squared. What is this value? It's going to be negative 5 is the coefficient of which variable? Of x squared. And then the other question, it says what is the exponent of the first term? Remember, in this case, we have already written our expression in a descending order. When you write it in a descending order, it's going to be like this. It is in the descending order. Can you actually see that the exponents are going down? All right. So if the question says, what is the exponent of the first term? We check the exponent of the first term. The first term is 4x cubed, 4x cubed. So the exponent of the first term there is going to be 3. Therefore, 3, right, is the exponent of the first term. All right. Is that fine? All right. So that is it. So can you see if we actually say the exponent of the first term? Can you check the first term in this case? The first term is the one which is having the highest degree. Ne? And therefore, if it is having the highest degree, you can actually say this is a third degree polynomial. Ne? It is a third degree, the degree, or yes, it is the polynomial of the third degree. Yes, you can actually see it there. It's a polynomial of the third degree. All right, I'm just going to give you some few minutes. I'm just going to give you, let me check. In this case, the activity that I'm going to give you, I'm going to state each of the following expressions is a monomial, whether it's a binomial, or it's a trinomial, or it's just a polynomial. And then from there, the other one there, you're actually going to write an expression, this expression in a descending power of x. Number 2, what is the degree of this polynomial? What is the value of the constant term? What is the exponent of the first term? Write down the coefficient of x. And then the last one, it will be, if x is equal to 1, what will be the value of the expression? All right. So I'm just going to give you, let's say 6 minutes. Can I give you just 6 minutes to do this? Because just state, this one is the monomial, this one is a binomial, and then from there you write number 2, this in the descending power. After that, you actually have to answer the question that followed. 6 minutes, I think 6 minutes will be fine. Let's take it in 6 minutes. All right. Now, let's actually check now. Let's check the activities. Remember, we said now we have to do this activity. State each of the following expressions is a monomial, binomial, trinomial, or a polynomial. So if we check at 1.1, in 1.1, we have a 2x minus 9. Can you see a 2x minus 9? It's just 2x minus 9. So if it is 2x minus 9, it is how many terms? It's first term and the second term. So we call it a binomial. Ne? Binomial. All right. 1.1. 1.2, it looks like negative 3 and x minus 4. So if it is like this, what type of a polynomial is this? This one. So in this case, there is only one term, so because of that, we call it a monomial, right? And then the next one, we have a 2xy minus 2x plus 3. Can you check there? It's how many terms? 2xy minus 2x plus 3. So 1.3 is a what? Is trinomial. It's 3 terms. No? You can actually check them. It's 3 terms separated by a minus sign, and the other one is a plus sign. And in this case, in 1.4, let's check how many terms. It's 1, 2, 3. Once it goes more than 3 terms, we say it's a polynomial. So 1.4 is a polynomial, right? And then let's go to 1.5. 1.5 is how many terms? It's 7x squared. Coefficient here is that. And negative 2x plus 1. How many terms? 1, 2, 3 terms. So if it is 3 terms at 1.5, we say it's a trinomial, right? Let's go to 1.6. Let's look what 1.6 looks like. It is a quotient of 4x squared minus 4x plus 1 out of 3x. Alright, so can you see that this is a single term because this is just one quotient. So because of that, we say this 1.6 is a monomial. Alright, let's go to 2.1. What is happening in 2.1? Oh, you are given an expression. 2x squared minus 3x to the power 4 minus x plus x to the power of 3. So 2.1 says, write the expression in the descending power of x. Therefore, you start with the highest exponent. So let's check. So which one is the highest exponent? Is exponent 4 is going to be negative 3 x to exponent 4. Which one is next? Is exponent 3. It is written positive x to exponent 3. And the next one is power of 2. Is exponent 2. Is 2x squared. So when it is written 2x squared, even though there is no plus sign there, we assume that there is positive 2x squared. Again, 2x squared. And then the last, no, it's not the last one. Yes, the last one. It's negative x. Can you see something interesting there? It's 1, 2, 3, and 4. There is it, all right? So we have actually written it in the descending power of x. Right, the second one, it says, what is the degree of this polynomial? Remember what it said about the degree of the polynomial. The degree of the polynomial, it is the highest power of that particular polynomial written in a descending order. So the highest one in this case, it is 4. So if we answer 2.2, it says, what is the degree of this polynomial? It will be the 4th degree. Fourth degree polynomial, right? Polynomial, right? In 2.3, the 4th degree polynomial in 2.3, we are looking for what is the value of a constant term. The value of a constant term. When you refer to a constant term, you refer to a term which does not have a variable, a term which does not have a variable. Can you see we see a variable here, we see a variable here, we see a variable here, we see variable here. So all these terms have variables. So the one which does not have a variable here, it is not there, and you cannot say it's not there. Therefore, if it is not there, it means the constant value is how much? 0. Yeah. The constant value is 0. It is somewhere there, even though it is not written, but there is plus 0 there. Can you see there? It's plus 0 there if it is not written there. So the constant, a constant term, or not a constant, but a constant term there is going to be 0. So what is the exponent of the first term? The first term in this case, our first term in this case became 3x squared. This is our first term. So when we're actually looking for the exponent of the first term, we are actually going to be referring to this. So 4 is going to be the exponent of the first term. Number 2.5. At 2.5, write down the coefficient of x. The coefficient of x is the number next to x, the coefficient of x. That you see there is x here, that is negative, and therefore it means the coefficient of x is going to be how much? It's going to be -1, because it will be a number next to x. It's going to be -1. At 2.6, let's say 2.6. At 2.6, we are having, what is the coefficient of x? It's 2.5. At 2.6, if x is equal to 1, what is the value of the expression? So in this case, they are saying, if in the position of x, it is 1 here, what will be the value of the whole expression? So what we'll be actually doing there, we'll be actually doing this when x is equal to 1. Therefore, the expression will be -3, 1 to exponent 4, plus 1 to exponent 3, plus 2, 1 to exponent 2, minus 1. Can you see that? So the value of this expression is going to be 1. All right. Is that fine? That's fine. Then let's go to our next activity. Our next activity will be actually going to focus on the expanding and simplifying algebraic expressions. But in this case, we are also only going to do addition and subtracting the like terms in an algebraic expression. All right. We'll be actually only doing expanding, not expanding, but adding and subtracting the like terms in the algebraic expression. All right. For example, in this case, if you are given this expression, all right, we already did this one. If you are given this expression, write the expression in a descending power of x and simplify. All right, I'm going to omit this one. Let's go to the next example there, which is example number 2. All right. Example number 2. In example number 2, we are going to be adding. What is this? We are going to add 2x. Can you see 2x minus 3y plus 2? We are going to add it to 3x minus 4y minus 3. All right? I'll be showing you shortly. So it's going to be looking like this. So when you add these, this is 2.1. When you add these, it's like, sorry, I've actually put them to there. It's a plus sign there. All right. So when you add this 2, it is like you can just put 2x minus 3y plus 2 on top of 3x minus 4y minus 3, and you add them. So when we add, we'll say 2x plus 3x, it will be 5x. It will be negative 3y plus negative 4y. In this case, it will give you negative 7y. Then positive 2 plus negative 3. You must be very careful. If it is positive 2 plus negative 3, alright, so it will be the same as positive multiplied by negative. It will be negative, according to the distributive property, is going to be negative 3, which is going to give us negative 1. Therefore, the answer here will be negative 1. So when you add 2x minus 3y plus 2 plus 3x minus 4y plus 3, you'll be getting 5x minus 7. All right. Let's add this one. Let's also add this one at 2.2. I'm also going to write it carefully. There is 3a minus 5b minus 7 added to half a minus 0,2b minus 1 out of 7. All right, let me show you what I've written there. There is it. So I'll be adding the two expressions. Okay, when I add the two expressions, the other one, this will be 3a minus 5b minus 7 added to half a minus 0,2b minus 1 out of 7. So when you add 3 and a half, you add 3a and a half a, you'll be getting 3 and a half a. You remember that? 3a, 3 plus a half. If you have 3 apples plus half apple, we're having 3 and a half apples. Is that easy? Yes. All right. Then 5b minus 0,2b, it will give you how much? Negative 5b plus negative 0,2b. Be very careful. It will be negative 5 plus negative 0,2. So this will be negative 5, positive by negative, negative 0,2. You'll be having negative 5,2. All right. So it means it will be 5,2b. And the next one there is going to be negative 7 plus negative 1 over 7. Negative 7 plus 1 over 7, negative 7 plus negative 1 out of 7, it will be like adding a negative 7 to a negative 1 over 7. So this is like just adding 1 and 1 and a half. It's going to be negative 7 and 1 out of 7. So it is going to be negative 7 and 1 out of 7. So there is it. As easy as that. But in this case, you must be very careful when you actually add your fractions. You must be very careful. You must actually know exactly how the fractions are added. You can use any method, but these ones are simpler because it is a whole number plus a fraction, which is a proper fraction. So you can just set 7 plus that proper fraction is going to give you a correct answer. All right. Let's check the subtraction. In the subtraction, now you are going to subtract the two terms. When you subtract the two terms, like in the case of a 3.1, I'm already going to write them in the form of 2c minus 3b plus x minus 2x plus b minus c. So it will be, in this case I'm subtracting now, it's Okay, I've actually typed x, there's a B, the C, and the C. All right, it's fine. All right, now let's do the subtraction. In this case, can you see that you cannot actually do this and this? Therefore, you have to write it in a correct manner. Write x on top of x, b over b, and c over b. So it has to be written as x minus 3b plus 2c, so that you can easily remove or easily subtract. So in this case, you're negative, you're going to subtract here. You're going to subtract 2x plus b minus c. All right, there is it. All right, can you see? I've just actually used the commutative property so that I can be able, I've just used the commutative property in this case just to arrange between the two. In this case, it was written as 2c minus 3b plus x. So when I have to subtract 2x plus b minus c, the 2x and the x were not corresponding, so I have to actually rewrite this. This is what we call the commutative. You take x to this side so that it can be able to be subtracted. It's commutative property. You take 2c to that side so that it can be like that. Let's start subtracting. It's going to be 1x minus 2x. It's going to be negative x. And then negative 3b minus b. It's going to be the same as negative 3 minus 1. It's going to be negative 4b. And then look at this one. It's going to be 2 minus negative c. So when it's 2 minus, it's 2c, minus negative c, this will be the same as 2 plus 1, which is positive 3. Can you see? You must actually remember your integers very well. This is going to be positive 3c. All right. This is going to be positive 3c. Is that fine? All right. So in this case, you would actually have added the subtracted this from this. And now the next one, be very careful. These are fractions now. All right. It's going to be this one and that one. So when you subtract those, you must be very careful because now you are working with fractions. The first fraction is 2 over 3x minus 5y plus 3.5. We are going to subtract 1 out of 3x plus 0.5y minus half. All right? It is going to look like this. Can you see this one? It is this one. We have to subtract now. We have to subtract 2 out of 3 minus 1 out of 3. All right? 2 out of 3, it's a 2/3. It's how many? It's 2/3. You subtract 1/3. You're going to be left with how many thirds? With 1/3. Can you get the logic there? It is 2 over 3 minus 1 over 3. The denominators are the same, and then you add or subtract the numerators. So you'll be adding 2 minus 1 is 1 out of 3. Can you see that? All right. And then the next one, negative 5, you subtract 0.5. So negative 5 subtract 0.5, it will be like negative 5.5y. You'll be adding this and this. Both of them will be negative, all right? In this case, it is 3.5. You subtract negative half. In this case, 3.5, the negative if you subtract another negative, it's like adding. So if there are 3.5 apples, you add another half apples, you get 4 apples. Can you see that? As easy as that. All right. As easy as that. And then from there, I just want to give you an activity here so that they can see whether you are actually following. In this activity, I'm just going to give you, let me just check quickly. I'm just going to give you 3 minutes to go through it. Can I just go? In 3 minutes, you'll actually be expected to finish this, but I'm just going to be demonstrating only one, and the other ones you'll actually do it on your own. Can you just quickly go through 1.1, 1.2, as well as 1.3? In 3 minutes, we'll be actually going to be finishing that. All right. All right, let us welcome back. So remember, in this case, we are just supposed to simplify this. When you simplify, you are removing the brackets and adding the like terms. All right. So let's check now. At 1.1, we had 2x minus 2 plus 3. So if we simplify this, we are just going to be adding, when you remove these brackets, because there is nothing that has multiplied there, it's like we're having 2x minus 2, you are adding it to a 3. And this will give you 2x negative 2 plus 3, it will be 2x plus 1. I hope you managed to get it correct. All right. And then the second one is 3x minus 5 minus 5x minus into 5x plus 5x. All right. In this case, therefore, you start identifying the like terms. Can you see there? There are like terms there. And also this one and this ones are like terms. Can you see that? So you can actually do the following. You can just say 3x, you can remove the brackets, minus 5y. And then this is going to be negative, because it's negative multiplied by this according to distributive property. Negative multiplied by 5 is negative 5x. Then the negative multiplied by positive 5y is going to also be negative 5y. And then from there, we can actually use the commutative property. And then you actually can group this one and this one together, as well as this one and this one together. If you place the other one next to the other one, it will be 3x minus 5x minus 5y minus 5y. And your answer will be 3x minus 5x is negative 2x. Negative 5x minus 5x, it will be negative 10. Not 5x, negative 5y minus 5y, it will be negative 10y. All right. Now let's go to this monster here. Oh, there is no monster, otherwise it is just the fractions. All right. Now, careful. In this case, we are adding a 0.25x to a 1.1 over 4x. And then we are also going to add negative 1 out of 8y to negative 3y. All right. But can you see that in this case we have a decimal, which is 0.25. On the other side, we have a common fraction. So it is either we convert both of them to decimals or both of them to common fractions. It's up to us. So we can actually see that in this case we have common fraction. We have a common fraction there. So we can also change this one to a common fraction, preferably so. So 0.25, 0.25, let's remember, 0.25 is the same as 25 out of 100. And if you simplify 25 out of 100, you'll be getting 1 in there, 4 in there. So it is the same as 1 out of 4. Can you see that? So it is a quarter of x added to another quarter of x. So in this case, when you remove the brackets, this will be 1 out of 4 x minus 1 out of 8y, which is added to another 1 out of 4x, subtract 3y. So in this case, when you remove the brackets, a positive, when it multiplies a 1 out of 4x, it gives you positive x. And the positive, when it multiplies a negative 3y, it gives you negative 3y. This is what we call the distributive property, okay? Because this multiplies this, also multiplies that, all right? And then from there, we can group the ones that are like, which is this one and this one, according to a commutative property. So this one and this one, it's going to be 1 out of 4x plus 1 out of 4x, and also this one, negative 1 out of 8y minus 3y. So we can add them. A quarter plus a quarter is a half. It's going to be half x. And then we go negative 1 out of 8 minus 3. It is negative 1 out of 8y minus 3 is going to be negative 3 and 1 out of 8y. Can you see that? So there is our answer there. All right. We can actually do it like that. So sometimes when you actually add these fractions, you can actually use the lowest common denominator, whereby you're actually identifying the lowest common denominator for negative 1 over 8 as well as 3. It is going to be 8. And then we say 8 is out of 1. We say 8 divided by 8 is 1. 1 multiplied by 1 is negative 1. 8 divided by 1 is 8. That is negative 40 there. 8 divided by 1 is 8. And 8 multiplied by 3 is going to be 24. And then you'll be having your answer as negative 1 minus 24 is negative 25 out of 8. Then you check how many times does 8 goes into 25. It goes 24, it goes 3 times, it leaves 1 out of 8, which is exactly the same as that one. But it's quicker when we actually understand your improper as well as the proper fractions. All right. All right. Learners, this is going to be the end of our lesson. So next time when we actually meet, we'll be actually maybe doing the multiplication of the monomials by binomials, as well as the monomials by trinomials, and then from there simplifying and removing the like terms. All right. So at the end, this is going to be the end of our lesson. So good luck for your practice. Remember, you have to practice every time so that you can be able to perform very well. So please keep safe, keep the social distance, and always wear your mask. Thank you very much.